Now we got one other kind of water. It's called hygroscopic water. Now this is water that the plants cannot pull from the soil. The soil has such an attraction to to water. Certain parts of the soil have such an attraction to water, they don't want to let it go. And if we don't have plants that have really good pulling power, they might not be able to pull it away. And therefore that water never leaves the soil. The plants don't have enough ability to pull it away from the soil. Now every kind of plant has a different capability there. And we'll look at that in just a minute. Now there is a point between gravitational water and capillary water where we have a thing we call field capacity. So in here, but in this area, I'll do it over here, we have field capacity. Now field capacity is, by definition, after you have saturated an area and let it sit for 24 hours, the water remaining after 24 hours is what we call the field at field capacity. So we've totally saturated it, let gravity do its thing for 24 hours, and after that point in time go out and test the moisture content in that soil, and that would be what we would call its field capacity. That's really the ideal amount of water we want in the soil.
Always 24 hours.
That's the standard when they're doing evaluation. If they're doing scientific testing, they use 24 hours delay. Saturate it and then do that. So gravitational water, if we're full with this, we call that saturation. So we're at saturation, and that's like 100%, all those pore spaces 100% full of water. We have saturation, we let it drain down, and we get, after 24 hours, we get to what we call the field capacity. Now we always want to water to field capacity. We don't want to water to saturation. We don't want to partially drown those plants. So we know that we're always going to leave some of those pore spaces open. We never want to fill the soil too full, okay? So we want to stay in this capillary water area, or what we call available water. Available water is the water obviously used by the plants. So that available water is going to operate between field capacity and a thing we call the permanent wilting point. Down here where we get into this hygroscopic water, we get to the permanent wilting point. Now that's a pretty descriptive word. Permanent, you know, that tells the story. It dies. When you take a plant to the point of permanent wilting, it means you literally dried it up to the point it cannot recover and it dies. So we have to manage our water somewhere between here and here to keep the plant alive. Well, we're sure not going to get ultimate growth if we stress this sucker right down to the verge of death. So yeah, so we want to find out another point, an intermediate point in there that we call the wilting point. So there's a point in there where the plant starts to wilt. And you can see that happening. The leaves start drooping. On a lot of plants it's pretty obvious. You go out and watch a cornfield in the middle of summer in the hot part of July on an afternoon, and you'll see the leaves start to curl up. You watch your house plants, those of you that grow house plants, you've probably pulled this trick. I've had a few hit the permanent wilting point, you know. I can kill a house plant pretty quick if I don't pay attention to it. But you'll see one of your plants all of a sudden is just drooping over. Well, it's hit the wilting point and it's in between here somewhere. If you don't get it some water in a hurry, it's going to be a goner.